Computer networking, day 7. Welcome back everybody. My name is Wisdom, your trainer for this entire series. So in today's video, we'll be dealing with TCP IP model. Without wasting much of your time, let's get down to today's class. Now let's see the outcome of today's lecture. At the end of today's lecture, you will be able to 1. Understand the layers of the TCP IP model, and 2. Understand how to troubleshoot using the TCP IP model. TCP IP model. The TCP IP model covers the many internet protocols, which defines how data is addressed and sent over the internet. Common internet protocols include HTTP, FTP, and SMTP, and all these three are often used in conjunction with the TCP IP model. Now, it is the same description as the OSI model, but the OSI model, while widely referenced, isn't used in the real-time world. The TCP IP model is, however, the real deal now. So just to spice things up, it is not that difficult. So if you have followed my videos on OSI model, TCP IP model won't be difficult for you to catch up with. It is a model designed to standardize computer networking. Now let's see what TCP IP model looks like. So we have 4 layers: layer 1, layer 2, layer 3, and layer 4. So layer 1 is network access layer, layer 2 is network layer, layer 3 is transport layer, and layer 4 is application layer. Okay, so let's compare these two models. So the OSI and the TCP model, this is the changes that has been done between the two of them. So the application, the presentation, and the session layer is now combined together to be called the application layer. The transport layer still remains the same. The network layer still remains the same. The data link and the physical layer is now combined together to form the network access layer. But then in the updated TCP IP model, the data link and the physical layer are now under the network and access layer. So let's see the protocols and some devices in each of these layers. So in the application layer, we have the HTTP, FTP, and SMTP, while in the transport layer, the two most common transport protocol are the TCP and the UDP. At the network layer, we have the IP. Routers also are found at this layer. Then at the data link and physical layer, which is the network access layer, we have the Ethernet and switches, which is found at the data link layer. And we have the cables and the NIC, network interface card, which is found at the physical layer. So from the source host to the destination host, so as we send data, each layer will add its own bit of information. Now this process is called encapsulation. So when we get to the physical layer, the data is being sent back to its destination, which is the receiving device. So this receiving device starts to de-encapsulate the data. Let's take a closer look at this. So we start with the application data at layer 5. This is then passed down to the layer 4, where the transport information is added. Let's say the TCP header. Each time a header is added, it contains a specific information. For example, a TCP header will contain things like the source and destination port number, sequence number, and a few more bits of information. We then move down to the network layer, where we add the IP header. This will contain the source and destination IP address as well as other bits of information. Lastly, we move to the data link layer. Here we add not only the header but also a trailer. The header contains mainly the destination and source MAC address, and the trailer contains some error checking information that the receiving side can check and make sure the data are received correctly. So once the data reaches the physical layer, it is physically transmitted. So I would like you to know that we have gone through the encapsulation process. Now it is important to know that at each stage, the data has a specific name. Now at layer 5, it is just called the data. Once the transport information has been added, it is now called the segment. And in the network layer, information makes our segment a packet. And finally, once we add our data link information, our packet becomes a frame. Now, once the data has been transmitted, the receiving device encapsulates the information. It will check the destination MAC address for that frame, and if the frame is destined for our computer, it processes it further. The computer now checks the IP information of the packet. Again, if the packet is destined for our computer, it's processed further. Now, lastly, the transport information is read and the application data is sent to the receiving application. For the physical layer, it is called the bits. So that is all for the TCP IP model. If you have not watched my OSI model explanation, you may like to go back and watch the application. And don't forget that your engagement on this channel will help this channel to grow and also make me to make more videos. Like, comment, and if you have any question you want to ask, drop it on the comment section below. Class activity. From what you have learned today, where does the encapsulation takes place? A. At the source host. B. At the destination host. Please pause the video for a while and carry on these tasks. Drop your answer on the comment section below. Thank you. That is all we have for today's video. Please, if you have not subscribed to our channel, please do that. Like, share, and comment if you learn anything. And please don't forget to do your class activity. Very important. So you can support by subscribing to the channel and also following us on our Facebook handle. Thank you guys, and see you in my next video.